glasses are fogging up really bad today. I don't like it when it's cold. Try to figure this out. I know, right? I know. Did anyone get a remainder they're willing to share yet? Still working on it. This time, setup looks good. Anyone on Zoom feeling brave and want to type the remainder they got in the chat? You can always type that privately to me or share it with the whole group. Remainder, working on it, refreshing your memory of how all of this works. I still see no answers in the chat. Shall we just do this one together? Or you want another minute to try it on your own? Think you got it? You want to be brave? What'd you get for a remainder? Like the number left over at the end. Okay. So let's see. Let's see if that's what we get. Old school style. I'm going to use this particular division algorithm, which would say that if I'm dividing 85 by 3, by the way, if I were to write that as a fraction, that would look like, sorry, my pens are cold this morning. 85 over 3. And when we're doing long division, the algorithm that we tend to use, at least in California schools, is that I'm going to put the 85 inside of this lovely division bar. I'm going to put 3 out in front. And the algorithm that we use is we're thinking, I need to multiply 3 by something to get close to 8. So if I multiply, but without going over. So if I multiply 3 by 2, then 2 times 3 would give me a 6. Next step in our division algorithm is that we're subtracting that 6. The result, 8 minus 6 would give me 2. And then we bring the 5 down. So now I'm looking at that and saying, 3 times what is going to get me close to 25? Because 3 times 8 is 24. And then when I subtract the 24, 25 minus 24, I would be left with a 1. Now, there were different ways that we could write this. Like back when you were a little kid, maybe you would write the answer as 28, like remainder 1. But the other option, and this is the one that we're going to use when we do polynomial long division, is that we can actually write that 1 as a fraction. Because this tells me that 85 divided by 3 is equivalent to 28 plus 1/3. So my denominator always stays the same, but the numerator would be the remainder. So this extra part is like the remainder over whatever the original denominator was. Before we move on to doing this with polynomials, are there questions about how I did this with numbers? That happens, right? And so that goes back to having your multiplication facts memorized and having them super quick is so helpful in this section and also in chapter 5. Like being able to multiply stuff quickly really does make a difference, and accuracy matters, right? Because if you make an arithmetic mistake, early on in the problem, then you might be doing totally not the problem that you're supposed to be working through. So accuracy matters, and that's why I'm going to continue when I'm grading quizzes and things. Computational accuracy is something we should all be working on in here. Okay, so moving on to have some fun with polynomials. Now, if any of you learn to do polynomial long division using synthetic division, that's totally fine. That is not a technique that I personally use. It's not a technique that our textbook uses, and it's not a technique that our calculus books use. But it's completely fine if you know how to do it, and that's how you want to get through the polynomial long division. I'm going to stick with the algorithm that looks very much like this. So my first example here, I'm going to have x squared plus 3x plus 5. And I'm going to divide this by x plus 1. In terms of our setup for the algorithm, whatever's in my numerator, that's what should sort of go inside of my division bar. So I'm going to have x squared plus 3x plus 5. And what goes on the outside is whatever was in my denominator. Now, unlike when we're working with numbers, there's lots of pieces to look at here. When I'm trying to do that first step of figuring out what to multiply by, we should always focus on the largest power of x on the outside. So no matter what's going on, I'm always referring back to this x. Just like when we did the long division with the numbers, we just looked at one number at a time or one digit at a time. Well, here I'm just going to look at one monomial at a time. And I'm going to ask myself, what do I multiply x by to get x squared? Totally. I'm going to multiply by x. And when we do the multiplication here, the one thing that's a little bit different, we didn't have to encounter it up there, is I'm going to multiply that x by both pieces of my denominator. So when I multiply this down, I'm going to have x times x and get x squared, and x times 1 to get an x. From there, same thing as if we were dealing with numbers. I'm going to subtract that. The thing to be careful about is that I'm subtracting the entire thing. So one option is to treat that subtraction as adding the opposite sign. Another thought is to just think about distributing that minus sign through. But I've got these lined up so that I want to look at x squared minus x squared so that I'm subtracting like terms. Well, x squared minus x squared would give me 0. And then I'm going to have 3x minus x. Again, sort of thinking about distributing that minus sign through. So 3x minus an x would leave me with positive 2x. Just like we did when we had numbers, after I've done the subtraction, if I've got something next door, I'm going to bring that down. Now I'm taking a look and saying, okay, x times what would give me 2x? And this time my answer is just a constant. It's going to be 2. And when I distribute the 2 down, the 2 is getting multiplied by the x. And it's also getting multiplied by 1. So 2 times 1 is going to give me that 2. And then we're subtracting that entire thing. And I choose to put it in parentheses because I want to remind myself that I'm subtracting both pieces. Another way to think about this, just like a little phrase that might help you remember, is when you draw the line, flip the signs. And that's kind of the approach that if you've been reading in the textbook, they flip the signs. So 2x minus 2x is going to give me 0. And 5 minus 2 would give me 3. Well, when I write the final answer, I'm not going to write x plus 2 remainder 3. We're going to write the answer as a fraction. So this ratio or rational expression is equivalent to x plus 2 plus 3 divided by x plus 1. So I'm following that same rule that my remainder goes on top. And we keep the same denominator on that fraction. So there's a question in the chat. And I am going to do my best to answer it. So the question in the chat is, why did we end up dividing by x? And I think that where that's coming from is how I got the x to put on top. So we're always going to, when we're doing the long division for polynomials, we're always going to look at the largest power of x in the denominator to decide what to do. So the question that we ask ourselves to get that x up there is we're saying x times what would give us x squared. And x times x is what gives us x squared. Because we're always aiming that when we do the subtraction, we're going to end up with a 0. Let's do one more example, and I'm hoping that this next one is going to help solidify that a little bit. So the instructions here of divide 3x squared plus 4x minus 1 by x minus 2. If I'm dividing by something, whatever's coming after the by, that's what's going in my denominator. So this is the same as if I had written this. Well, that means that the 3x squared plus 4x minus 1 is what's going on the inside, and my x minus 1 is going on the outside. Just like in the previous problem, x is what I'm going to focus on. So I'm going to ask myself, x times what would give me 3x squared? Well, this time it's going to have to be 3x. The objective is that when I take the 3x times x, I should get exactly what I need to make that first term cancel out. Distributing the multiplication through, I'm going to have 3x minus 1, or sorry, 3x times negative 1, which is going to give me a minus 3x. And then we're subtracting that whole thing. Again, I'm lining things up so that I'm always subtracting like terms. I've got 3x squared minus 3x squared to get 0, which is really the whole point. And now I've got 4x. I'm being careful. I have 4x minus negative 3x. Well, subtraction is the same as adding the opposite sign. So that means this is really like saying 4x plus a positive 3x, and I'll have 7x. Then I can bring down that negative 1. Now I'm looking at this and I'm focusing in on the x and the 7x. So what would I need to multiply x by to get 7x? I got to multiply by 7. So I'll have 7 times x, and then 7 times a -1 will give me a -7. And I'm subtracting the whole thing. So if we're careful about those signs, 7x minus 7x would give me 0, which is the point. And -1 minus -7 is going to leave me with a +6. The last step is just to write our final answer with our remainder as a fraction. So I'm going to get 3x plus 7 plus 6 over x minus 1. Questions about this guy? I'm hoping that helped to answer the question in the chat a little bit more. But we're always looking at the biggest power of x out in front to decide kind of what's the thing we need to multiply by. Let's do one more example together, and then I'll give you another one to try on your own. So I'm gonna give us a messier one here. How about x cubed 2x squared minus x is 4 over okay. Come in focus. Okay, I've got x cubed plus 2x squared minus x plus 4 all over x squared plus 1. Well, if I write this, that means that my entire numerator goes inside. So I've got x cubed plus 2x squared minus x plus 4. And outside, I would have x squared plus 1. Well, this time, because I'm going to be looking at the largest power of x in the denominator, I'm focusing on the x squared. First step, I ask myself, x squared times what is going to give me x cubed? And the answer here is an x. So I'm going to multiply that x down and distribute it to my entire, to like both pieces from the denominator. So I'm going to have x times x squared, which will give me x cubed. And then I'm going to be careful about lining things up here because I also have x times 1, which is going to give me a positive x, but I'm going to choose to write that directly underneath my x so that when I go to do the subtraction, I'm subtracting like terms. So x cubed minus x cubed, I'm going to have 0. Because I don't have anything to subtract here, it's like I have 2x squared minus 0x squared, or just that 2x squared. And now I've got negative x minus an x. So I've got negative 2x. And then I can bring down my plus 4. On my next step, I'm thinking about X squared times what will give me 2x squared? And our answer is a positive 2. So when I distribute that down, 2 times x squared, I've got 2x squared. And 2 times 1 will give me 2. And I'm going to do the same thing and make sure that I line up that 2 over here with the 4. So that I'm always subtracting like terms. Numbers from numbers, x squareds from x squareds, x's from x's. And when I subtract all of that, 2x squared minus 2x squared gives me 0. Negative 2x minus nothing is still negative 2x. And 4 minus 2 would give me 2. Now this is actually the point that we need to stop in our polynomial long division. And I know that I'm going to stop because we got to a place where the power on x down here is less than the power of x that we are referencing in our denominator. So we're going to stop here. Because the power on x is less than the power. I'm going to write this as actually negative 2x. So it's like the whole term. The power on negative 2x is less than the power on x squared. So that's how we know we're sort of done with the long division. And it's time to write this as that whole big thing is equivalent to x plus 2 plus that remainder we just got, so negative 2x plus 2, all over that denominator that we started with. There was kind of a lot going on in this problem, so I will pause just for a second in case you've got questions in the room or online. Okay. Oops. So try this one on your own. So we're going to divide 3x squared by 3x squared plus 5x minus 2 by x plus 2. And if you're hanging out on Zoom, when you get to an answer, type your remainder in the chat, just because that's the easiest thing to type in. And I'm not sure if I've ever mentioned this, but if you have joined us on Zoom, even if you have your video on, it doesn't become part of the recording. So you are always welcome to turn your video on and it'll never show up in the recording. If you unmute yourself to talk, that will show, your audio will come in the recording, but never your video. I'm going to mute myself and give folks a couple minutes. give it about 1 more minute. Also, the auto transcript, it's kind of fun to watch sometimes, especially when it gets things really wrong. Okay, I'm starting to get some numbers through on the chat. We have numbers in the room, and we've got to get for a remainder. Some good. Got something. Got something for a remainder? Maybe. We'll see. Okay, I got a few through the chat. Okay. Let's give it a shot together. So to set this up, I'm going to have 3x squared plus 5x minus 2 on the inside and x plus 2 on the outside. So just like with, let me move it up. So just like with the other ones, I'm focusing on that largest power of x. When I think about this, x times what gives me 3x squared? I saw a bunch of 3x's as I was walking around the room. So when I multiply that down, I'll have 3x squared, and 3x times 2 would give me a positive 6x. And when we do the subtraction here, something a little different than what had happened on previous problems happens. So 3x squared minus 3x squared gives me a 0. But then I've got this 5x minus 6x, which means I end up with a negative x. And then I'm going to bring down that negative 2. We're not done. And the reason I'm not done at this point is I know I'm going to stop when the power on x down here is lower than the power of x over here. Right now they're the same. So I've got to go one more step and think about x times what gives me negative x. And that number is negative 1. Negative 1 times x, I'm going to write a negative x. And negative 1 times positive 2 would be negative 2. That's a whole lot of negatives. But when I subtract this, negative x minus negative x is 0, and negative 2 minus negative 2 is also 0. If you get 0, that means there is no remainder. It means that we would just say that 3x squared plus 5x minus 2 divided by x plus 2 is equal to 3x minus 1. And that would be your answer. The answer you would report out is 3x minus 1. Okay, we've got some questions in the chat. So first question basically was, what happens when you get 0 for an answer? This is what happens when we get 0 for a remainder. There is no remainder. We say that this divides exactly. Same thing that would happen if we were dividing a number by another number and we got a whole number for an answer. We just say that it divides exactly. We could also say that this means that x plus 2 is a factor of 3x squared plus 5x minus 2. We'll get back to factoring starting on Wednesday. Next question in the chat is, how did we know to use a negative number? So the key here is that in order to make the whatever we're looking at completely go away when we subtract it, we need it to be exactly the same, like same coefficient and the same sign. So if I want negative x to go away when I subtract, I have to make sure that I end up with a negative x. And the only way to do that is if this is -1, so that when I distribute the -1 in, I've got -1 times x, and then -1 times 2. Should we get another one going? Okay. Kind of going to go through some of the like weird things that can happen. So how about if I have x cubed minus x minus 4 divided by x minus 2. I need to make sure, I'm going to let everybody write that, but then I'm going to ask like, seriously set down your pencil. I'm going to write incorrect math things, and I don't want them to end up in your notes on accident. Okay. I'm going to write some things that this is not equal to. One of the, maybe the most common algebra mistake that seriously is very detrimental to a grade on a calculus exam is to look at that and have your brain start trying to cancel things out. To have your brain look at those x's and have your brain look at that -4 and -2, and to somehow come out with an answer that looks like x cubed plus 2. Now, if you're looking at that going, huh, awesome, because that's the wrong thing. It's not what it's equal to. But I have seen a lot of canceling that looks like having addition or subtraction on the bottom. And your brain like wants to cancel those x's and wants to simplify the -4 and the -2. Not how we have to deal with the division. Because the x minus 2, that's like together as one piece because we've got addition or subtraction going on down there. If everything was multiplied together, so if I had like x cubed times -x times -4 over x times -2, this one I'm going to simplify all day long. This one correctly, my -x over x would become a -1, and the -4 over -2 would become a -2. So if everything is being multiplied together, that's when we have this option to sort of cancel things out, right? Because what we're doing when it's multiplication is we're saying, oh, I'm multiplying by -1. I'm multiplying here by 2. Over here, if you were to make that a 1 and that a 2, it would be like you were adding things together. So I'm just making my plug that please, please, please watch out for this mistake, because in the next couple sections, it's going to be really easy and tempting to make that mistake. Okay, now we're really going to do it. So I've got x cubed minus x minus 4, and we're going to divide that by x minus 2. We're going to do this the correct way. We'll just get that out of the way. So if I'm doing this the correct way, I'm going to take x cubed. Now, notice if our powers were going in descending order, we're kind of missing that x squared piece. So I'm gonna leave a little space for it. And sometimes you might even want to put in a 0x squared kind of as a placeholder. So when I do this long division, I'm looking at the x. And I'm saying x times what gives me x cubed? Well, that's going to be x squared. When I distribute that down, x squared times x gives me the x cubed that I was looking for. And then x squared times -2 would give me -2x squared. So the reason that I like to have a placeholder is to make sure that I can line things up vertically and subtract like terms. X cubed minus x cubed is 0. And now it's like I've got 0x squared minus a -2x squared. So I'll have positive 2x squared. And bring down my -x. Next up, I'm still going to refer back to this x term. So x times what would give me 2x squared? That's going to be a positive 2x. 2x times x, that's 2x squared. 2x times -2 would be -4x. We're subtracting that whole thing. 2x squared minus 2x squared gives me the 0. And -x minus -4x is a positive 3x. And then I can bring that -4 down. We're still not done because our power on x down here is the same as the power of x we were dividing by. Well, x times a positive 3 is going to give me that positive 3x. So I'll have 3x, 3 times -2 is -6. And when we subtract that, 3x minus 3x is 0, -4 minus -6. It's like adding the opposite. So -4 plus positive 6 gives me a +2. And I'm going to write that final answer as x squared plus 2x plus 3 plus 2 divided by x minus 2. Dun, dun, dun. Pausing for questions. Drinking some tea. Yeah, so, oh, go ahead. So to know when to stop, for sure, if you got down to just a number, you're done. Like, I think that's the most straightforward one. If you got to a number, you're done. If this is just like hypothetical for a second, but let's say that we were doing some kind of long division and up here I had x squared plus x. I don't really care what's inside for a second. And I get down to something that is like 2x plus 1. I'm going to stop because that 2x has a power of 1 and that x squared had a power of 2. For this same problem, it might work out that you get down here and kind of that last term was just a number. Well, for sure, we're also going to stop. Because a number is technically like a power of 0. not seeing other questions in the chat. We definitely have time for another example. Should I give you one to try? Shall I make it challenging? Maybe. I just made this up. I don't know what's going to happen other than I'm sure that the powers don't match up super well. So give that one a try on your paper. And we know we're going to stop since this has a largest power of x squared. We know we're going to stop when we get down to either a number or just an x. just to make sure we actually get to finish this before we run out of time, I think I'm going to go ahead and roll through it. If you're on Zoom, you can always mute me if you're going to keep trying to work through it on your own. So my reference here is going to be the x squared because it's the largest power of x in my denominator, or what I'm dividing by. So x squared times 2x squared is what I would need to get 2x to the fourth. So I'll have 2x squared times x squared to give me 2x to the fourth. And when I distribute this down, 2x squared times x would be a positive 2x cubed. So in case you missed it, I gave myself the space with a 0x cubed and a 0x so that I could make sure that when I do the subtraction, I'm subtracting like terms. Well, 2x to the fourth minus 2x to the fourth is 0. 0x cubed minus 2x cubed would give me a negative 2x cubed. And then I'm going to bring down my x squared. On my next step, x squared times what is going to give me that negative 2x cubed? I'm going to need a minus 2x. Distributing that through, I'm going to have negative 2x cubed. And negative 2x times x would be negative 2x squared. I'm subtracting that whole thing, lots of minus signs in there. But negative 2x cubed minus negative 2x cubed is 0. And 1x squared minus negative 2x squared would give me a positive 3x squared. I guess we could say, and then I'm bringing down the 0x. So plus 0x. Well, x squared times 3 is what's going to give me the 3x squared. And 3 times x would be a plus 3x. And then I'm subtracting that whole thing. 3x squared minus 3x squared gives us 0. And 0x minus 3x gives me a negative 3x. And then I'm going to bring down that 1. But now I'm going to look at this and say my power down here is less than the power in my original divisor. So I'm done. And I'm going to say my answer is 2x squared minus 2x plus 3 plus negative 3x plus 1 divided by x squared plus x. Good times. Yay, polynomial long division. I am out of time, so I'm going to stop the recording.